We've been having trouble merging into the repo lately, either the SONiC Dash or the regular SONiC repo. Let me try and turn off my camera and share my screen. Sorry, it's taking a second here. Sorry, guys, my CPU seems to be pegged. I don't know why, so I'll try and share my screen while we talk. So yeah, so the repos have needed to have an update, and what that means is all the PRs have kind of been blocked for the last week and a half, 2 weeks. Can you guys see my screen now?
Yes.
Oh, awesome. Okay, great. So what we have then essentially is all of these in progress in yellow items, simply because we either can't get a merge or even something that's passed through review. We still need to get a merge for that. I did talk to Junhua and Riff last week, and we got these two closed, which was more about behavioral model and whether we'd be able to do these two things, the write back table entries and the underlay routing in the behavioral model. So I did get an update from Junhua and Riff there. So if you guys have PRs that you've been waiting on, that's why. And so I noticed that Marcia, you had a question here. You were chatting with Riff about the
Yes.
private link. Yeah. And it looked like you had a second question, like a follow-up about, does the VM know how to use the fake
No, it's the same question. My question is from the perspective of the on-premise computer or of the VM. How do they know the destination MAC? Usually, let's say a Linux PC or whatever, it just looks at the neighbor table or the ARP table, and it has a IP MAC pairs, and it gets it from there. And if it doesn't, sends an ARP or NDP or whatever and figures it out. So, but the Riff answered to me from the perspective of the smart NIC or whatever, the smart switch. I didn't ask how the smart switch knows. Sure, the smart switch has a site configuration, but how does the VM or my PC on premises knows what is a MAC, the destination MAC? That was, and he answered partially. He said, "Okay, they put a bogus MAC. Okay, how does it? Where does it put this bogus MAC? Because if I have a standard Linux PC, it's gonna wanna find the MAC for that IP. And even if there is a bogus mechanism, okay, what's that mechanism that puts the bogus MAC for each of these IPs? Because if I have 64K services, I'll have 64K IPs. So there will be a table with 64K IP MAC pairs. Okay, bogus MACs, but somebody needs to fill that table. So that was my question to him, is like, okay, how does it know about those MACs? The VM or the PC?
Luckily, we have Riff just joining. Go ahead. Sorry, Riff.
Yeah. So, because this has been a little while, so I kind of forgot the exact detail it is. But what I remember is that when the traffic is sent out through the from the VM to the network, we actually in Azure we have a driver over there. And then driver will actually rewrite the destination MAC to a fake MAC. So that's essentially how it does.
So the kernel will initiate an ARP, and the driver will fake a response basically to populate the table.
And not really fake the response, because to the VM, I believe, is going to the gateway, and the gateway is basically the MAC address of the tool. The fake MAC comes in when the inside of the virtual network layer on the node or on the host where the VM is running. So when the packet going through the host, it gets rewrite into the fixed MAC. If what I'm remember is right.
So there is a gateway. Is the routing happening here, or do we?
No, there is no gateway. Is
Okay.
the gateway. I mean the row table gateway. So if you want to send to somewhere via some IP, so that's the gateway. It's not really gateway. It's just like IP, or routing gateway. But that's there is no gateway service over there doing the rewrite. I think it's all done in the kernel drive.
But from networking perspective, from the VM or whatever, the on-prem computer, does it see all these as a, let's say, like a layer 2 network where everything is in the same domain, or actually it has a gateway and the routing actually happens?
On-prem is slightly different. So because on-prem, what it happens is the traffic comes into either from the MSE routers, right? So those packets get routed differently and then gets encrypted differently. That is actually different scenario.
Okay, for the VM scenarios then, does a VM sees all these services IPs like being in the same domain? Same slash 24/10 something, or actually there is a gateway?
Yeah, that's a good question, but I don't have the node access now, so I could not really answer.
Why I'm asking this is because if they're in the same domain, it's not gonna put the gateway MAC, it's gonna put each IP MAC, which will result into 64K IP MAC pairs in the ARP or neighbor table or whatever you want to call it, or the NDP table. So that's what I'm saying. Who's responding to these 64K ARPs? And okay, then the driver is gonna fake the response and just populate the table so the kernel can create the packets with some destination MAC.
I don't really think it will populate both into the table because if you have like say 1 million mappings over there, it will be like huge, unsustainable.
No, I mean the scale here it's 64K per ENI, so let's say it's only 64K entries per VM. Okay, a VM could have multiple ENIs, but that's let's say a different use case.
Essentially, you're looking at the whole CAP mapping, right? So every CAP mapping is basically essentially one of your names. Yeah, so I don't. If I remember correctly, it's actually not going to populate like all the MAC entries into it with ARP response. That's why like the MAC address coming out is fake. It just simply doesn't care, and it gets rewrite afterwards in the pipeline.
I mean, it doesn't care, but the Linux kernel cares. If it doesn't have a MAC, it's not going to put the packet on the wire. That's my problem.
So you're with let's say.
So problem that I have right now is that we have the smart switch, yeah, and I create a VM. Yeah, but Mircea VM is not Azure VM.
Yeah, but
and
so Masha, if you what if you do this? If you so you don't really need the MAC address for every single neighbors, and you need right. So when the packet sent out, you say, oh, if the packet is sent to this subnet, please go to say this subnet this subnet.1, and it will use the .1 to find the MAC address, and the MAC address can be just one single thing. So you don't.
So then there is a gateway, and then routing happens.
Yeah, but you don't need the I think the MAC address for every single neighbors that you have.
If it's a flat network and they're all in the same domain, it's layer 2. It will have the MAC of every single one. That's what I'm trying to figure out. If it's like a /8 or whatever, and everybody sees everybody, then yeah, it's gonna have a table with 64K entries if you want to access all 64K services. And if it's a gateway and routing happens, then there is a bit more configurations than it seems to be from the description of the scenario.
Yeah, but I really don't think then it will actually happen, because if you think about just the regular VM case, you can have 1 million VMs in your subnet, and that, yeah, it's not going to scale.
So how can we find out how this is working, or what's happening in on the VM side?
Is this something you want me to ask? Oh, sorry, Riff.
Yeah. So the one thing that we could do is to create an Azure VM just to really log in and see. But if you need the details, we need actually inside of Azure we call it like node access or something like that, to execute the node stack, which essentially need the node the permission, or we call it JIT. But you only get access if you are working in a team. Because I moved from SDN to Finance, so I don't have the access anymore. I have to try. So
what if I just rent a VM in Azure? Okay, we have our own account, and I'll just rent a VM and try to access couple of services, whatever. I'll just start 2-3 services and then do a IP neighbor on my Azure VM and see if I actually have all these entries in the table or not.
Yeah, that should work.
Yeah.
As an experiment.
I can also run this by the SDN team too, Marsha.
Yeah,
okay.
yeah.
Thank
so
you.
Christine, all you need is just someone run process topo, really. I just don't have the access, otherwise I'll just run it directly.
I'm sorry, what'd you say, Riff? All I need is what?
Process topo.
Okay. All right. So I will see what I can do with that, Marsha, over this week. Is this a high priority, Marsha? Like P0, P1?
I mean, for now, what I'm doing, I'm putting manually entries in the ARP table. I'm just inserting them and creating IP MAC pairs, millions of them, just to be there. But I was curious how it's happening actually in Azure.
Okay. Sounds good.
By the way, Masha, talking about the implementation, I actually have a maybe ad hoc question, if you don't mind taking maybe
sure
5 minutes with me. So in the is there any issues if we would like to test, say, something like fast pass, because then is we need to fake a ICMP redirect package after the TCP.
So similarly, it's something that I do right now. So basically, the smart switch or the SONiC is not forwarding the ARP packets, but I see the kernel issuing ARP before start sending any traffic for the destination IP. And what I do, I have a way to actually respond to those ARPs, but it's me responding. So it looks to the kernel like I give them a response, or I manually program them in the ARP table with IP neighbor. In order to have, and currently I'm not putting a fake MAC, I'm actually putting the same, I'm matching the MAC, so whatever MAC it's in the smart switch mapping table, I put the same MAC here. As of now, if I'm to put let's say a wrong one or a fake one, sure, I'll put a fake one. And then if we go to the fake problem, I have the also question is like, okay, if you are to make 64K fake MACs, are they all going to be the same? Probably not. So then they need to be different. And how do you not make it collide with something else? Do you have a special, first 3 groups of characters, the first 24 bits, whatever, that you have designated for those fake MACs? So if we are going the fake MAC route, I wanted to know how are you coming up with those fake MACs? It's just something completely random, or
yeah, it's a hard-coded MAC anyway. it's not completely random, but
Okay.
it's a hard-coded special method.
Okay.
Yeah, thanks, guys. Switching topics, Riff, since you're here, I wanted to let you know that Jing is going to go ahead and review this one here, SWSD. So just FYI on that. Jing's taking care of that.
Okay, yeah, sounds good.
And yeah, and then it looks like we had a, add a channel tunnel key to HA. I know the reason I'm bringing it up is because I know you're into the HA stuff. So looks like Marian had one here. To
yeah, I vaguely remember I left a comment there.
Yeah, you did. Yeah. So it was about UDP, right?
Right. So yeah, not sure if Marian is in the meeting. Can take a look.
He's here, yeah. Yeah.
Riff, so a clarification here. You're saying that this is only restricted to UDP layer, not beyond that. So you will put a different UDP port.
Right. Because if we say it's VXLAN, then by definition VXLAN have a specific like the port number, and most of the people use this different port for its own like VXLAN. Same thing in Azure. So that's
how
why
do you intend to forward
to
this packet?
Destination port.
So the forwarding is happening because we don't provide the VIP, we provide the peer IT as a destination.
Mm-hmm.
Okay.
Yeah.
Okay, good.
And right, because the VXLAN itself, it doesn't really or that layer doesn't really matter so much. It's just like as long as the port is different, we're going through like different paths. So that's why like in the HLD, we only have the destination port being specified, because the only thing that we are worried is that the port is actually conflicting with other services that will run into some problems over there. So we have the destination port being set, but internally, if you are using VXLAN or using any other the protocols like Geneva or whatever, it's all good.
Yeah, that's fine. I was just trying to understand if there will be no problem with forwarding if we would use different destination port, but we have a peer IP, then we will be fine. Yeah.
Yes. We have the peer IP. Yeah, sounds good.
Okay, good. And I do want to point out that Prince Sunny from the SONiC team actually had mentioned that, if anyone had time to help with ASIC DB optimizations, that would be a good one to work on in the future. I know a couple of teams had asked about important work items, so I think this is similar to what they did in the app DB, and so that one's available. And then we had another question here. I bet you this is Mircha. Let me see here. Yeah. Since traffic
is about the ratio. So basically, since for private link, most of the traffic is from the VM or whatever, the on-prem to the service, the inbound ACLs doesn't seem to require a huge quantity. So far for VNet to VNet, I had it like 50-50 split, since, it's okay to have both in and out for most use cases. So my question was if for private link, we're going to maintain kind of a 50-50 ratio, or I don't know, just don't allow any inbound and have all the ACLs as outbound rules.
So this would be more of an SDN question then?
Yeah, or some other ratio, I don't know, where they're like, hey, we have few ACLs for, internal Azure purposes. But
yeah, because the first two stages are Azure, and the third stage was customer. Go ahead.
Mircea, you cannot have inbound as denial, right? There will be a fast path packet coming from the service, right? So that you cannot have inbound as just denial.
Why not?
No, then fast path packet, ICMP redirect packet will be dropped, right?
Dropped.
I mean, it's the service sending packets randomly to the VM at any time, initiating,
No,
or
not
they're all
to the
responsive?
VM. No, not to the VM, to the SmartNIC for the ICMP redirect fast path.
It probably won't drop the fast path
Yeah.
like SMP redirect. The reason is that the echo is actually works on the the overlay layer, not underlay layer. And SMP redirect is probably not counted in the the overlay layer. It's more like the info packet, so it will actually go through. If the implementation actually have that expectation, but Moshe, I think we probably need to be a little bit more specific on this one. Is that is this on-prem or is this like the VM?
Whichever scenario we want to test for the private link.
Okay, I see.
From my perspective, personally, I'm not invested in one or the other, but I thought that maybe it's not going to be 50-50 because most of the traffic it's outbound only for this scenario. So this is why I ask. I'm like, hey, we do 50-50 for VNet. Maybe for private link, we do some other distribution of ACLs to keep it more realistic. But otherwise, I can keep it 50-50, and have a bunch of ACLs that probably is never going to be exercised.
Be used, yeah.
Yeah, but just to fill the table. Yeah, this is not urgent or anything. It's just to make the test more realistic.
Sure.
That sounds good. Yeah, because the what I feel is because here it mentions it's outbound only, then I think it's more like the on-prem scenario. In this case, because VM scenario is more like mixed. Is going to talk with PL and also going to talk with other VM. So then will be slightly different. But in the on-prem case, then it's like outbound only. So in that one, then the ratio is very likely to be different because there is no income, the so-called like income traffic. However, in a floating NIC case, the order packet going through the inbound and then going through the outbound, so then will also be slightly different as well. So yeah, we can probably like follow up on that offline.
Okay. Two more for HA, just so you know about them, Riff. This one about initializing HA Manager D. This one came in and it's being worked on, it looks like, from Cisco.
Mm-hmm.
Just FYI.
Yeah, this is a connector to SW Bus D. Yeah.
Yep. And then another one was implementation of DPU actor. And that's Fred again. Yep.
Yeah.
Yep.
So I had a question around that ASIC DB optimization.
Okay.
I don't know if I asked in this call or the other
Different
conversations about what the profile data you have and what is the optimization that you're targeting or expecting. And this, I think any of the DPU vendors are up for it, or this is similar to how we optimize AppDB. Okay.
And I can ping Prabhat to see if he has prior PRs on this.
Okay.
And yeah. Do that here. And then I also noticed this one coming in just version fields. So this is Prabhat. He has a draft going, not much documented in that. I guess this turned into a longer meeting than I thought it was going to be. And also just FYI, guys, the high-level design for the Graceful Shutdown, the DP Graceful Shutdown, was last Thursday, presented in the Linux Foundation call, and I know those are recorded. If that's something you want to go listen to. Is that right, Ref?
Yeah, this one, Ramesh, I think, presented
Ramesh did that.
last week. Yeah, so I think more or less we have agreement, I think, with Vasundhara, Alexander, and others, right, Gagan, or Alexander? I don't know if they're on the call.
Vasundhara, yeah.
Yeah. I believe there were a couple of minor comments which doesn't affect the overall design. So we are just pending for update of the HLD, and we are ready to approve.
Sounds good. Thanks, Alex.
And I don't mean to cover Smart Switch stuff here, but it all kind of ties together, and it's a lot of the same audience. So, okay. And like I said, Riff, you weren't in the call, but all of these in progress, we're just kind of waiting on merges for, we have to get that pipeline update done. It's nothing we can do. It's just that's why there's so many. And that's all I have for this week. Did you guys have anything you wanted to cover? I know, Marian, you had two pretty low priority ones that we were tracking here and here. But like you said, they're lower priority. Great. Well, that's all I had for the week. Thanks for coming. I can give back a half hour of time. Yeah, thanks for coming, Ref. Yeah, and Mircha, I'll try and connect us with the SDN team on the 2 sets of questions.
Sure. Thank you very much.
All right. Thanks for coming, everyone.
Thank you.
Thanks, Morali.
Thank you.
Okay.
Bye-bye.
Thank you.
Have a good one.
Bye.
Bye.